The James Webb Space Telescope, or JWST, is a space telescope that NASA, the European Space Agency ESA, and the Canadian Space Agency collaborated on. The telescope is named after NASA Administrator James E. Webb, who served from 1961 to 1968 and was a key figure in the Apollo program. It will supersede the Hubble Space Telescope as NASA's flagship astrophysics mission. James Webb was launched on Ariane Flight VA-256 on December 25, 2021. It will enable a broad range of investigations across the fields of astronomy and cosmology, including observations up to redshift Z20 of some of the universe's oldest, most distant events and objects, such as the formation of the first galaxies and detailed atmospheric characterization of potentially habitable exoplanets, and will provide improved infrared resolution and sensitivity over Hubble, viewing objects up to 100 times fainter. The optical telescope element of James Webb's primary mirror is made up of 18 hexagonal mirror segments composed of gold-plated beryllium that come together to form a 6.5-meter diameter mirror. This offers Webb's telescope a light collecting area roughly 5.6 times larger than Hubble's 2.4-meter mirror. James Webb will view in a lower frequency range from wavelength visible light to mid-infrared than Hubble, which observes the near ultraviolet, visible and near-infrared spectra. This will allow it to observe high redshift objects that Hubble can't see because they're too old, dim or far away to observe faint infrared signals without interference from other sources of warmth. The telescope will be deployed in space near the Sun-Earth L2 point, a point in space about 1.5 million kilometers from Earth, where its 5-layer kite-shaped sunshield can protect it from warming by the Sun, Earth and Moon at the same time. James Webb's telescope was developed by NASA's Goddard Space Flight Center in Maryland, and it's operated by the Space Telescope Science Institute. Northrop Grumman was the primary contractor. The project started in 1996 with a $500 million budget and an initial deployment date of 2007. A major redesign in 2005, a ripped sunshield during a practice deployment, a recommendation from an independent review board, the COVID-19 pandemic, issues with the Ariane 5 rocket and the telescope itself, and communications issues between the telescope and the launch vehicle were among the many delays and cost overruns. The intricacy of the telescope and the high-stakes nature of the launch were noted by the media and scientists and engineers. Space explorations, discoveries in the unknown, and questions about our existence. If these intrigue you, then subscribe to our channel Facts Pulse and keep exploring the vastness of the universe. After the construction phase was completed in late 2016, thorough testing commenced. James Webb Telescope was launched by an Ariane 5 launch vehicle from Kourou, French Guiana at 12:20 on December 25, 2021, and was released from the upper stage 27 minutes later. NASA praised the launch as flawless and excellent. The telescope has been fully and successfully unfolded to its operating configuration as of January 8, 2022, and is continuing to travel to its target location. It will take several weeks to cool to its operational temperature, after which it will go through final testing and calibration processes for about 5 months, possibly including the acquisition of its first photos before beginning its intended research program. The 4 main goals of the James Webb Space Telescope are as follows: to look for light from the universe's initial stars and galaxies that emerged after the Big Bang, to investigate the genesis and evolution of galaxies, to comprehend the genesis of stars and planets, to research planetary systems and life's beginnings. Observation in near-infrared light, rather than light in the visible half of the spectrum, is more effective in achieving these goals. As a result, unlike the Hubble telescope, James Webb's equipment will not measure visible or ultraviolet light, but will have a considerably better capacity for infrared astronomy. JWST, James Webb, could be used to study the diminishing light of KIC 8462852, a star found in 2015 that has certain unusual light curve qualities. The farther away an item is, the younger it appears, since its light has taken longer to reach humans. Because the cosmos is expanding, light becomes redshifted as it travels, making objects at great distances easier to perceive when viewed in the infrared. The infrared capabilities of James Webb's website are projected to allow it to see back in time to the formation of the earliest galaxies, just a few 100 million years after the Big Bang. Infrared radiation can penetrate through patches of cosmic dust that scatter visible light more freely than visible light. The study of objects and regions of space that would be covered by gas and dust in the visible spectrum, such as the molecular clouds where stars are born, the circumstellar disks that give rise to planets, and the centers of active galaxies, is made possible by infrared observations. Spitzer and the Wilkinson Microwave Anisotropy Probe (WMAP) are two infrared astronomy missions that influenced JWST's development. Spitzer demonstrated the importance of the mid-infrared, which is useful for tasks like studying dust disks surrounding stars. Scientists and engineers who worked on the project expressed their excitement and apprehension about the roughly $10 billion instrument's launch, saying it would be an amazing moment and that they would be terrified the entire time. Bill Nelson, the administrator of NASA, described the successful launch as a terrific day for planet Earth. The telescope was confirmed to be receiving power, allowing it to begin a 2-week deployment phase of its components and proceed to its intended destination. The observatory was linked to the Ariane 5 through a launch vehicle adapter ring, which might be utilized by a future spacecraft to grasp the observatory in order to correct massive deployment issues. However, unlike the Hubble telescope, the telescope is not maintainable, and astronauts would not be able to undertake chores like replacing equipment. The telescope's mission is expected to last 5 years, with a 10-year aim. James Webb Telescope must utilize fuel to preserve its halo orbit around L2, known as station keeping, to avoid drifting away from its orbital position. The Ariane 5 launch precision and the initial mid-course correction were credited with conserving enough onboard fuel that JWST may be able to sustain its orbit for roughly 20 years instead. Thank you for watching, and we'd love to keep you updated on all our future videos. So hit the subscribe button and the bell icon to be a part of our Facts Pulse family.